So V of A is equal to omega 1 cross R of OA. And that's 3k multiplied by this vector that we got up here. So this vector here. This vector, this one. 72.1 I plus 69.3 J. And we end up getting negative 208 I plus 216 J. Now the velocity of A, we know the time rate of, we know the time rate of change of position, so R dot was 216 millimeters per second. So we can represent that in terms of displacement in the y direction. So that was purely about a rotating, or in the rotating frame of reference, it's only in the y direction. So our R dot is equal to R dot J, which is equal to 216 J millimeters per second. And our omega BC term represents the angular velocity of the arm BC. So we can write velocity of A in terms of R and BC. So VA equals R dot plus omega BC cross R of CA. CA is that vector from this position to this position. If we got this fixed, and this is our arm, and this is our rotating arm that's going like so. So we can then see that our RCA is a constant value which we've been given in the question statement, which was RCA equals 361 J millimeters. Now we know that our omega BC term, this is a vector and this is also a vector, our omega BC term is in the k direction, but it's unknown. So we're trying to find the rotation of BC. So the R dot term represents the velocity of the block A sliding backwards and forwards along this block, while BC is not rotating. The term omega BC cross RCA represents the velocity of the block rotating, or the block A rotating with bar BC without any sliding motion. So just the rotation of A. So just that rotation. If we combine both terms, then we end up getting the velocity of A, the total velocity of A, or the block A, which is, it can be represented like so. R dot plus, these are all vectors, R dot plus omega BC cross R of CA, but we already know what our vector V of A is, which is equal to 216J, we know that, plus omega BC K cross 361J. And our velocity of A we've already found, and that is negative 361 multiplied by omega BC, because that's an unknown in the I direction, plus 216J. Now if we go back to our equation for the V of A, which was somewhere, it's up here, we can look at our, so that's our equation 1, this is our equation 2, 1 and 2. If we equate the coefficients, so our coefficient of I and j components, so that we can see 216, 216, they correlate, but negative 208 and negative 361 omega BC, we can solve for omega BC by equating the coefficients of I. So negative 361 omega BC is equal to negative 208. Therefore, our omega of BC is equal to negative 208 on negative 361, which is equal to, so let me plug that in the calculator. We get 0.576 radians a second in the counterclockwise direction. And we can see that the velocity of B at an instant is given by V of B equals omega BC cross R of CB, which is equal to 0.576k cross 500 J, and this is with respect to our rotating frame of reference. This J term is only in the rotating frame of reference. So our velocity of B, if I plug it in the calculator, we end up getting a velocity of B as negative 288 I millimeters per second. Okay, so our velocity of B is this. Velocity of A in terms of omega BC is this. Our position, time rate of change of position, this is a vector, is this value in here. Our velocity at A found another way is this. And our omega of BC is this value in here. So we've found everything that the question wants us to do. Thanks for watching this video. I hope it's been helpful.